Welcome to Sir RP's channel. In this video, you're going to learn how to solve combined variations. Are you ready to learn? Sit back, relax, and get ready to learn. You're now on the last type of variation, which is combined variation. It is a type of variation that consists of at least two different types of variation, including inverse variation. Results of this type of variation are varied, wherein one increases, the other two may either decrease or increase. For example, the time it takes to finish a task is directly proportional to the number of tasks to be done, and inversely to the number of persons doing the task illustrates a combined variation, which is composed of a direct and an inverse variation. As the number of tasks increases, the time increases. However, as the number of persons increases, the time decreases. Take note that in combined variation, you are combining at least two different types of variation, including inverse variation. Combined variation takes place when one quantity varies directly or jointly as the other quantities and inversely as other quantity. Take note here that combined variation takes place when one quantity varies directly or jointly as the other quantities and inversely as the other quantities. So it can be direct combined with inverse or joint combined with inverse variations. That is combined variations. The equation of combined variation is a mathematical representation of a combined variation depends on the variation statement. For example, y varies directly as x and inversely as z is written as y is equal to kx over z. K is still the constant of variation. In this example, we have the combination of a direct variation and an inverse variation. For example, if y varies directly as x and inversely as z, and y is equal to 12 and x is equal to 4 and z is equal to 9, what is the equation of variation? To find the equation of variation, transform the variation statement into a mathematical sentence, substitute the values of x, y, and z to solve for k, and write the equation by substituting k to the original equation. We now have our equation, which is y is equal to kx over z. Then substituting the values 12 for y, 4 for x, and 9 for z, we now have 12 times 9 is equal to k times 4. 12 times 9 is 108. Then divide by 4, it's equal to 27. So it's just 108 is equal to 4k. Then divide both sides by 4 to find the value of k. That is 27. From there, you substitute the value of k to the original equation, giving you y equals 27x over z as the equation of variation. Next, write the equation for the statement n varies directly as p and inversely as q. We have here the answer. N is equal to kp over q. Again, it's a combination of a direct and an inverse variation. Second example, if y varies directly as x and inversely as z, and y is equal to 12 when x is equal to 3 and z is equal to 5, what is the equation of variation? This is similar to the previous example. First, translate the variation statement to an equation. Y varies directly as x and inversely as z. That is y equals kx over z, combination of a direct and an inverse variation. Solve for k using the values of y, x, and z. Just substitute the values of y, which is 12, x, which is 3, and z, which is equal to 5. We now have 12 is equal to k times 3 times 5. Then 12 times 5, and then k times 3 times 1. So that is 12 times 5 is equal to k times 3. Then 12 times 5 is equal to 60. K times 3 is 3k. Then divide both sides by 3. You will now have 20 as your value of k. That is your constant of variation. Since you now have the value of the constant of variation, you now substitute the value of k to the original equation to determine the equation of variation, giving you y equals 20x over z. 20 is our value of k in the previous line. That is now your final answer for the equation of variation. Y is equal to 20x over z. Another example. The variable r varies jointly as s and t and inversely as v. Find the variation constant in the equation of variation that relates the variables if r is equal to 12 when s is equal to 6, t is equal to 3, and v is equal to 3. Now, we have a joint plus inverse, okay? A combination of a joint variation and an inverse variation. The same process, translate first the variation statement to mathematical sentence, then substitute the values, find the value of k or the constant of variation, and then write the equation of variation. Here it is. R is equal to KST because it varies jointly as S and T and inversely as V. Then you now substitute the values R 24, S6, T3, V3. 6 times 3 is 18. Then 24 times 3. You now have this. 6 times 3, 18. And then 24 times 3. So you now have 72. Divide both sides by 18. That's 1. So your value of k is 4. Since you now have the value of k, you can substitute the value of k to the original equation, giving you the equation of variation, which is equal to r equals 4st over v. That is for the equation of variation. Next, fourth example. If d varies jointly as a and b and inversely as c, and d is equal to 20 when a is equal to 2, b equals 5, and c equals 3, what is the value of d when a is 6, b is 7, and c is 4? We will first solve the first part. Okay? If you now have the value of k and the equation of variation, move to the second part, finding the value of d with the new values of a, b, and c. To solve that, translate the variation statement to an equation. D varies jointly as A and B and inversely as C. This is a combination of joint variation and inverse variation. So that is D is equal to KAB over C. Substitute now the values of A, B, and C, then D. So you have 20 for D, 2 for A, 5 for B, and 3 for C. 2 times 5 is 10, and then 20 times 3 is 60. Then divide both sides by 10. Your value of k is 6. From there, write now your equation of variation, which is just equal to d equals 6ab over c. Take note that we have another problem. After finding the equation of variation, our next goal is to find the value of d given the values of a, b, and c, which are 6, 7, and 4 respectively. Substitute now the values. 6 for a, 7 for b, and 4 for c. 6 times 7, and then times 6, okay, then divided by 4. 6 times 6, 36 times 7, then divide by 4. That is, you can divide first 36 and 4, so that's 9 times 7 is 63. Or you can multiply 36 and 7, then divide 4. It's just the same as 252 divided by 4. It's still 63. Okay, either of the processes. And that's now your final answer. D is equal to 63 when A is equal to 6, B is equal to 7, and C is equal to 4. Therefore, the value of D is 63. Fifth example. If y varies directly as x and inversely as z, and y is equal to 24 when x is equal to 48 and z is equal to 4, find y when x is equal to 63 and z is equal to 6. combination of a direct and an inverse variation. So just follow the steps presented a while ago in the previous slides. You now have y equals kx over z. Substitute the values. Then you now multiply. 24 times 4 is equal to k times 48. 24 times 4 is 96. Then you now divide both sides by 48 to find the value of k, which is 2. From there, you write the equation of variation by substituting the value of k to the original equation, that is y equals to x over z. Then find y when x is 63 and z is 6. 2 times 63 divided by 6, y is equal to 21. This is the complete solution. And for the last example, the volume of a gas varies directly as a temperature and inversely as pressure. If the volume of a gas is 800 milliliters at a temperature of 25 degrees Celsius with a pressure of 40,000 Pascal, what is the volume of the same gas at a temperature of 28 degrees Celsius with a pressure of 80,000 Pascal? V varies directly as T and inversely as P. Write your equation, then substitute the values. 800 for V, 25 for T, and 40,000 for P. 800 times 40,000, you will get 32 million equals K 25 times 25. Then divide both sides by 25, you will get 1,280,000 as your value of K. Then you now write your equation of variation. Just substitute 1,280,000 to K. You have now 1,280,000 times 28 divided by 80,000. The final answer, or the volume of the gas at temperature of 28 degrees Celsius and a pressure of 80,000 Pascal is 448 milliliters. Just divide this two. This is the final answer. Okay. For your independent practice, if t varies directly as the square root of u and inversely as the product of v and w, and t is 1/3 when u is 16, v is 6, and w is 4, what is the value of v when u is 9/4, t is 9, and w is 1/6? For your answers, please use the comment section. That ends our session for today. Thank you, Quipper, for the slides used in this presentation. Once again, thank you and happy learning. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.